So I would like to know who is from mechanical and who is from aero background. So you guys can write your responses. You can also unmute yourself and speak, right?
Hi, sir.
Hi.
I am from Aerospace department.
Okay, nice. Okay.
Hi
So,
sir, this is Bharat.
yes.
I'm from mechanical background.
Okay, nice. Anybody else would like to speak or write in
Hello,
public
sir.
chat? Hi.
I'm from aerospace background and myself Tunga.
Okay, nice to meet you. Okay, so and Sajid is aeronautical engineer. Okay. I think most of you are from aerospace background. Few of you may be from mechanical also, and you may be preparing for GATE aerospace. I think all of you are preparing for GATE aerospace, and some of you might also want to write GATE mechanical engineering, right? I think you guys are aware of this, that you guys can simultaneously apply for two papers: aerospace mechanical engineering, and third one is engineering sciences XE. I think you guys are aware about this much. Right, so okay, 1 second. We'll write few things about GATE exam. I think you guys, but I think most of you know, but if somebody does not know, I will tell you. Okay, so you guys, most of you have done your UG or undergraduate in aerospace, right? UG in aero. Most of you are from there, and some are from mechanical also, right? And you guys are writing GATE exam for aerospace engineering and mechanical engineering. I think this is the combination which we have in this batch, right? You may be writing for both or one of those exams. And one more option you guys can choose is XE, which is engineering sciences. Okay, so is this part new for somebody? This XE part? So should I explain about this more, or you guys know about it? Because in last batch actually there were few students who did not know about XE exam, so that's why I'm asking if you guys are aware, or somebody would like to know like what is this subject in GATE. Okay, it's new for you. Okay, no problem. Okay, so in aerospace, okay, I will write few things. Like in aerospace engineering, we broadly divide it into four parts, right? One is aerodynamics, basically four domains. One is structures, other is propulsion, then we have controls, right? So so this is the four domains in which aerospace engineering is divided broadly. So in aerodynamics, you get your fluid mechanics, you get your, there is one, actually the domain name is aerodynamics. There is one more subject which you will study, which will be called aerodynamics also, subject with the same name. Then there is one subject you will study, gas dynamics or compressible flow, right? These three subjects you will study in aerodynamics domain. Then there is structures, where you will have strength of materials or machine dynamics, something like this. Then propulsion will be your thermodynamics and related subject, applied thermal, like Brayton cycle, power cycles basically, Rankine cycle, those kind of things you will study. Steam turbine, steam compressor, axial flow compressor, these kind of things you will study in propulsion domain, right? Then control is basically electronics part of aerospace engineering, right? So in last batch also, actually there were one or two students who were having electrical or electronics background, but they wanted to write GATE aerospace engineering because they want to go into controls, right? So for them, controls is a nice step to enter into aerospace engineering field. For people who are in who are doing their undergraduate in aerospace engineering, you guys must have studied all four of these parts in your BTech, right? So some basics about all of these four domains. So for you, all four of these domains are okay to proceed in, like if you are going for masters or something like this. For people who are coming from mechanical background, for them actually aerodynamics is very nice branch because it has fluid dynamics, compressible fluid dynamics, those kind of things. And then you have structures where strength of materials will be used, machine design will be used for people from mechanical background. Then for propulsion, you guys already study thermodynamics, applied thermal engineering, right? Power plant engineering, those kind of things will be used in propulsion. For mechanical people, actually controls is a very new topic. If somebody writes GATE aerospace engineering, he is from mechanical background. And then for masters or PhD, if you want to go for further studies and you choose controls, being a mechanical background student, then it's actually quite difficult for you to continue, because either you prepare your base separately, you study basic electronics, you study basic about sensors, actuators, those things, basic mechatronics, either you study those parts, then you will be able to enter into controls. Otherwise, other three domains are very nice for you. Then actually in ISC, one of my friend was from civil background, also civil engineering. So civil engineering people, they study strength of materials. So his area of interest was these structures. So you can say aerospace engineering is kind of an interdisciplinary branch. So people from all the departments can write this aerospace engineering paper, right? Okay, so this was about aerospace engineering. Then we have mechanical. So people who are writing GATE mechanical engineering exam. So again, broadly, we will divide into let us suppose fluid and thermal part, where you will have fluid mechanics, you will have heat and mass transfer, then you will have fluid machinery, hydraulic machinery, then other subjects like applied thermal engineering, like basically IC engine, power plant engineering, refrigeration, air conditioning, those parts will be there. Then for mechanical, other thing is design part. In design, we basically study SOM, strength of materials, theory of machines, and then machine design. These are few subjects. Then there is production engineering or manufacturing part. Production or manufacturing part. This is for people who are writing GATE mechanical engineering exam, right? And then there is something called industrial engineering, right? It is basically related to something called, you can say, increasing productivity of a production system, related to this, so little bit related to MBA basically, right? Business administration. Then we have, okay, so design, fluid, production. Yes, these are the main departments in mechanical engineering, right? So whenever either you write GATE in aerospace engineering or mechanical engineering, it doesn't matter. Fluid is the common part in both of these cases, right? Now we will talk about GATE exam. So all of us know it is 100 marks exam, right? Where you get 70 marks of your core, whatever you have prepared, and then 30 marks for maths and aptitude, which is common for all the papers, right? So this 70 marks is what you are preparing for during your BTech. Suppose you may be from aerospace engineering, so this will be your 70 marks. Then from mechanical, your mechanical core will be there, right? Then there comes one new paper which is called XC, or which is called Engineering Sciences. Actually, I will say this is kind of a loophole for people who want to go for further studies, for postgraduate studies, MTech or PhDs, because IITs, ISC, they take students who have written GATE XC also for their MTech PhD programs. XC actually is a very nice exam for people who have started very late in their preparations. Why? Because in XC, you will get your 30 marks paper, same, maths and aptitude. Right. Then there is 70 marks paper. It is divided into actually two sections. Section number A or B. I will call it A and B. Actually, they are different. Okay, so I will not call them A and B because, okay, let us say this is section 1, this is section 2. Each will be of 35 marks. And for you have to solve this for 30 marks, this for 35, this for 35. Whole will make your 100 marks paper in XC, right? Now, what options do I have for section 1 and 2? I have actually three options. One is fluid mechanics, one is thermodynamics, one is strength of materials. So if you have good command over any two of these three subjects and mathematics and aptitude, you can go for XC exam. Let us suppose, so GATE exam is in February, right? Let us suppose by the month of November or December, you think, okay, for this year, actually I'm not discouraging you guys, but still I'm telling you reality, what happens. Let us suppose by November or December, you feel like, okay, so I haven't paid much attention to my preparation and only 2 or 3 subjects I have studied properly, other subjects I haven't studied, right? Let us suppose you have good command over fluid mechanics and thermodynamics, or thermodynamics and strength of materials, or any of these two subjects. Instead of going for complete aerospace or complete mechanical, you can go for XC, because there you can score better if you have command over any two of these three subjects and mathematics and aptitude. With that score also, you can get your seat in IITs or IISc for MTech or PhD if somebody wants to go for post graduation. And but if somebody's aim is to go for PSUs only, so let me tell you, they do not take XC people. They will not take XC people. So for PSUs, XC is not good. But for post graduation, for MTech or PhD, you can easily go for XC paper. Okay. So this was. If you still have doubt, you can again go to ChatGPT, or you can open Google and search about this paper. So actually, there are few of my friends who are in ISC by September, October, when they were filling their GATE forms. So they filled both of these things, like mechanical and XC or aero and XC. They filled two of these papers. One of their paper went bad, either mechanical or aerospace engineering. But only due to XC, they were able to get their seat in ISC. So it's a good option to keep. So I will suggest you guys to explore more about this paper. So it since last 3-4 years, when GATE has allowed for two papers, so this ME plus XC is a good combination, or Aero plus XC is a good combination. I will not suggest you guys to go for ME plus AE. I will not suggest you this, because see, it is possible. I'm not telling you it is not possible, but still, you will have huge chunk of syllabus. You have to get good command over that part, right? So there are few topics in fluid mechanics also. When I will discuss the syllabus right now, after a few minutes, I will tell you there are few topics which are not in aerospace engineering. If you are writing mechanical paper also, you have to study that extra part. But then you are a mechanical student. For aerospace engineering, you have to study that controls part extra, right? You are from CSC department. Can I take GATE aerospace engineering? Yes, you can go for GATE aerospace engineering. It does not matter, but study properly. That's what I can say. While you are in your preparation phase, you have to. I think you are from CSC. You have done your BTech from computer science engineering, right? So in class 11th or 12th, you may have studied these things: fluid mechanics, thermodynamics, stress strain curve. These kind of things, I think, you have lost these things for last 3-4 years. But being a computer science student, I'm telling you, yeah, you studied for JEE also, but still, I'm telling you that after JEE preparation, since you have done your BTech for last 2-3 years, whatever in whichever year you are, you have lost your touch from these topics, right? So study these things properly when teachers are teaching here in IGC. So you will get a good command over these topics. And if you are comfortable, by the time GATE forms are filled, I think by September, I think GATE forms are filled. If you feel confident enough, just fill for GATE aerospace engineering or XC mechanical, whatever you feel comfortable in. And what, oh, you want to go for aerospace, right? So you can fill aerospace engineering paper. But I will still suggest you guys, like these topics are actually very basic topics: fluid mechanics, thermodynamics, and strength of materials. If you guys you have to have good command over these topics to write aerospace or the mechanical, whatever subject you are writing. But still, I will suggest you guys to go for XE also, because it's a nice option to keep. And if you still have doubt about this paper, you can search over it, right? Search over internet. Okay, so we will come back to our current topic. Okay, so let us start this fluid mechanics part. Okay, so one of you can write in this chat like how many subjects you have done and which subjects are those. Any of you, if you can speak, or you can write in the chat. So anybody has idea? Like, yeah. Hello. Tell me.
It is a demo class for me, sir.
Actually, your voice is not clear. Could you write in public chat?
Yeah, I haven't joined the IGC yet. This is my
Yes.
demo class.
Okay, this is your first class.
Yes,
Okay,
sir.
okay. Actually, okay. Actually, I thought a few subjects have been taught for this batch. Okay, no problem. Okay, so we will start fluid mechanics. See, this is GATE Aerospace syllabus. Okay, somebody is writing engineering mathematics has been done. Okay, so few students first class is there, and few students have already studied some subjects, right? Flight mechanics, engineering mathematics, and I think aptitude has also been done, right? Reasoning and aptitude. Okay, so it doesn't matter much. Okay, so those of you who have already studied engineering mathematics, so for you, these topics will become a little bit easier. So I just wanted to tell you this. Nothing. So no need to be afraid about any of this thing. Okay, so this is the official GATE Aerospace Engineering syllabus from GATE website. Okay, so the part which they have written is, so they have named this domain as aerodynamics, and you have basic fluid mechanics, potential flow theory, aerofoil and wings, compressible flows, and some special topics. Right. So this compressible flows and this special topics, this part you will study in gas dynamics. Potential flow theory, airfoils and wings. This part you will study in the subject called aerodynamics. Right. I will be dealing with this part, basic fluid mechanics. Okay. So this part, they have written only few words about this part: conservation laws, mass, momentum and energy, integral and differential form, dimensional analysis and dynamic similarity. So they have written only this much, a single line syllabus. But this course will take around 15 lectures with 2 hours each. Around 32 hours it will take to cover this single line of syllabus. Okay. Then we will see what is the weightage for this exam, for this subject. So this basic fluid mechanics, they usually ask around 3 to 4 marks, but in GATE 2022 they have asked for 7 marks. So you never know like what they will ask and how much weightage they will give. But yes, okay, so we will generally take 3 to 4 marks for this subject. For mechanical people, the weightage is quite more. It's 6 to 9 marks out of 65. So out of 65 out of 70. So you can say it's around 12 to 13% of your GATE exam. And for mechanical people, they have explained syllabus quite well. They have explained all the topics: fluid properties, fluid statics, forces on submerged bodies, stability, flowing bodies, and these things you can read on your own. Okay. Okay, so for my class, I would like to tell you a few things initially. Whenever class is going on, close your pens, close your notebooks, just listen what I'm telling you. Okay, you will only open your pens when I will give you a question to solve. Whenever I am teaching, don't write anything. After the class is over, I will share these notes with you. You go back again, watch the recorded lecture, then make your own notes. Okay, so because few students have this habit of writing simultaneously when class is going on, so it will not benefit you in any way. You will not be able to write everything, and you will also not be able to hear anything. So it's better to be, because you already have recorded lectures, right? You will get these recordings. Don't worry. So just focus on listening what I'm telling you. So this is the complete syllabus which we will cover in this part. And for gate mechanical people, the weightage is 6 to 9 marks. And this is our course content. So this is the common syllabus for both aerospace and mechanical students. Doesn't matter you are going for aerospace engineering or mechanical engineering gate exam. These are the topics which are only specific for mechanical engineering people. So in this course, 30 hours, I will cover this part. And this part I will leave for later. Okay. So people who are writing for aerospace engineering and mechanical engineering, both of you can attend these lectures. People who are only writing for mechanical engineering, for you also these lectures are important, but for you the extra lectures which we will deliver sometime later, those lectures will also be important. Okay, so the topics will start with fluid properties, what are the basics of the fluid mechanics basically. Then we will enter into pressure measurement topic. Then finally hydrostatics. Hydrostatics basically means fluid at rest, right? Then fluid kinematics. Kinematics means motion without a cause. We don't know what is the cause of the motion, but motion is there. We will study what motion is there, right? Then we will enter into fluid dynamics domain. Fluid dynamics means there is a motion and we know the cause, basically forces and torque. We will deal with those things in fluid dynamics. Then we have laminar or viscous flow, basically pipe flow we are talking about, or flow over flat plates. Then some very little introduction about turbulent flow. Very little introduction part will be there, right? We will not enter deep into turbulent flow territory because this is not into your syllabus. Only basic turbulent flow is there in your syllabus. Then we will enter into boundary layer theory. It is quite important topic. Fluid dynamics and fluid kinematics. These topics are very important for you. Then vortex flow, which is a little bit of vortex flow is actually a part of fluid kinematics, but I like to deal it at a later stage when you have developed some concepts. Then we have dynamic analysis and similarity also. We will study in this thing. So these are really important topics for you guys. This pressure measurement, kinematics, dynamics, boundary layer theory, dimensional analysis. And you can say this laminar part also, laminar or viscous flow, where you will study, I think you guys have heard these name, Poiseuille flow, plane Poiseuille flow, Coet flow. So those kind of things we will study in this chapter. Okay, now people who are going for gate mechanical engineering, so for them few topics will be added apart from this syllabus. In fluid properties, there actually one more property which is called as surface tension, which I leave while teaching this common part, because it is this surface tension part is not in the aerospace gate. So I teach it for mechanical people only. I will give you a very brief introduction about surface tension, but I will not enter very deep into this topic. Right. Then we have a complete chapter on buoyancy and flotation. So those parts, this part is not in aerospace engineering, so we will deal with it later. Then there is flow through pipes. Flow through pipes basically means losses, flow losses, bend losses, major loss, minor loss, those kind of things we will deal with. And pipe networks, pipes in series, pipes in parallel, those kind of things we will deal later. Then there is a new topic which has been added in the gate after 2021, I think, 4 years ago. Basics of compressible flow for mechanical people. For aerospace people, you study this compressible flow as a complete subject called gas dynamics. But for mechanical people, very basic things of compressible flow were added in the fluid mechanics part only. Right. Okay, so next. Yes. Okay, so I will tell you few reference books. See, these are called reference books. Reference means you do not have to read them completely. You just have to you have to refer these books whenever you are not able to understand anything from these lectures, from your notes, or from anywhere else, then you refer these books, right? There is one book called Sengel and Simbala. Few people call it Schengel or Sengel, whatever you like to call it, and Simbala. It's a very nice story-like book. Whenever you will read any topic, you will feel like book is talking to you. It's very good book for concept building. Then we have F.M. White, Frank M. White. He also has a very nice book for good concepts and good numericals. Then we have Som Chakrabarti and Biswas. It's a more mathematical kind of book. Most of the topics they have explained in mathematical way, not with the physical approach. Right. Then we have K. Subramanya. He has written a book with 1,000 problems in fluid mechanics. So it's very nice book for problem solving. If you guys want to solve some nice problems, you can refer this book, which is for thermodynamics. Angel? Okay. See, this person, Angel, this guy is actually a heat transfer person. So he has a book on heat transfer, right? Then he collaborated with another author called Bowles, Sengel and Bowles. Then they wrote a book on thermodynamics. Then he collaborated with another person called Simbala, Sengel and Simbala. Then they wrote a book on fluid mechanics. So this person is common, and with Bowles he has written thermodynamics. With Simbala he has written fluid mechanics. I'm talking about Sengel and Simbala fluid mechanics. Right, you can easily get these PDFs online, so don't worry about it. Okay, so this Subramanya, 1,000 Problems in Fluid Mechanics. It's a very nice book for problem solving. Then you have your basic book by R.K. Bansal. If you want to solve very basic numericals, like you have read the topic for first time, and you want to solve very easy questions to build up your confidence, to build up the concept, you can go with some solved numericals, solved examples of R.K. Bansal. Once you have made enough foundation, then you can go to Subramanya and you will get very nice problems in fluid mechanics. Right. So these are the, you can say, authentic sources for your sub concepts and for your problems, for problem solving and your concept. If you have no one to teach you anything, you can read the concepts from these books, you can solve the numericals from these books, right? But here what we are doing, we are teaching you, we are giving you notes, we are giving you we will solve few questions in the class also, and you guys will also get some assignments also, some test series also, so you guys will have enough material. So I don't think you will need to go to these books much, but still you want to, like I have completed one topic and you want to solve, let us say, 8 to 10 very nice questions, you can open Subramanya and you can open that topic and you can solve those questions, so you will get some confidence, right? So you will have enough number of sources here, like from our notes and questions. Whenever I'm completing one lecture, I will share these notes with you, and each topic will have few questions with it also. We will solve few questions in class. One or two questions I may give you in homework also, and we can discuss those questions in next class, right? Then you have gate previous year questions. See, fluid mechanics is a subject which is common in 4 papers: aerospace engineering, mechanical engineering, XC engineering sciences, and civil engineering. So you can get n number of fluid mechanics PYQs. So if somebody wants to see aerospace engineering and mechanical engineering PYQs are must. You have to solve these previous year questions at least 3 to 4 times before GATE exam. But if you really want to study some so you want to solve some really good PYQs, you can go for XC. XC has some really good PYQs for fluid mechanics or for thermodynamics or for strength of materials. For any of these three subjects, if you really want some good PYQs, you can check XC previous year papers. And few people who are from civil background, they may be familiar with civil paper also. So civil actually has questions with in hydrostatics topic. They have questions. Open channel flow, actually it is not in your syllabus, but they have some basic fluid mechanics, fluid kinematics, fluid dynamics, those kind of questions they also have. But I will suggest you guys to definitely do these aerospace and mechanical previous year questions. And if you want to build up your concepts a little more, you can check this XC. And civil, only if you have much time left, then you can go for civil PYQ also. Right. Then you will have your test series. You will write. I think once the subject is over, you will have to give some few chapter wise test or few complete subject test also. Then you will also get some assignments. And then still, if you have some time, then you can go for engineering services PYQs. Actually, the nature of GATE and engineering services is different. GATE basically focuses on numericals, and engineering services focuses much on theoretical questions or conceptual questions. So I will still suggest you guys to focus on GATE PYQs only. But still, if you have some time and you think that okay, I will like to practice some conceptual questions also, then you can go for engineering services PYQs also. But just don't go further than 5 to 10 years. Okay, no need to do for last 30 years or so. Okay, for GATE you can go for last 30-35 years, whatever you feel like. Okay, so this was okay. So we will have around 15 lectures, 2 hours each. So our subject duration will be around 30 to 32 hours. I would like to complete this part in this much time. Okay. So any doubt till now, or should we start?
Sir, what is the weightage for theory part
Nobody
and
knows.
problem solving, sir?
Nobody knows. See, you can tell weightage for subject. You cannot tell that what is theory and what is numerical. Still, GATE people, you will find more than 70% or 80% of paper will be numerical based only. Only 15 to 20% you will get some theoretical questions like conceptual 1 mark questions only. And those will be easy to solve if your concepts are clear. But most of the questions, 75 to 80% of GATE exam is numerical based.
Okay.
So
Sir, the
subject
notes will
wise,
be,
I cannot. Yeah, tell me.
sir, the notes will be shared where, sir?
I will upload it in Google Drive and I will share the link with you guys.
Okay.
Okay. Okay. So anything else? Okay. So about notes, one more thing I would like to tell you. At the end of the lecture, I will share these notes and you will get a download link in this public chat forum also. This public chat, you will get a download link. I think it takes around 30 seconds or 40 seconds to upload. So you guys can download these notes from here also. Otherwise, I will actually we have a Google Drive link also. So I will upload these notes in Google Drive. So you will have two methods. Suppose you are not able to attend a class, right, due to something, and you are not able to attend live class. You think, okay, I will watch the recorded lecture. Okay, so recorded lecture is okay, but how will you get the notes? So public chat is only accessible during live class. So for that, we have made a Google Drive link also. So I will, after class, let us suppose 2-3 lectures are over, I will upload those notes in the Google Drive. And you guys will get the Google Drive link also. Okay. Is there anything else you guys want to ask, or should I start? Okay, so let us start. So our first topic for fluid mechanics is fluid properties, right? So I think most of you guys who are from mechanical aerospace background, so you guys have studied fluid mechanics in your BTech, right? In your undergraduate studies. So this subject starts from fluid properties. So this chapter will have these topics. First of all, I will tell you what is definition of a fluid. Then we will see what is fluid versus solid. What is the difference between fluid and a solid, right? Then I will teach you this concept of continuum, then no slip phenomenon. Then we will enter into the domain of fluid properties. What are various kind of fluid properties there? Then we have a topic called Newton's law of viscosity. Then we have Newtonian and non-Newtonian fluids. So these are the topics which we will cover in this chapter. So I am planning to complete these topics in let us say 3 lectures, including today's lecture. Okay. Okay, let us start. So we have our topic, name of our subject called fluid mechanics. Right. We have this subject called fluid mechanics. Now you guys have studied mechanics in class 11th or 12th or while preparing for JEE anything. Right. So what is mechanics? Mechanics is study of rest or motion, study of a system at rest or motion. Whether a system is at rest or it is moving. We study what kind of properties change during that. Okay. Then for fluid mechanics, basically we study the system here is fluid. So this is called fluid mechanics. So we will study whether the fluid is at rest or at motion, and if it is at rest, what kind of things we can get out of it, what forces it is applying, what is the pressure behavior, those kind of things. If fluid is at motion, what is its velocity profile, what is the velocity potential function, what is the acceleration of the fluid flow. So those kind of things we can study in this subject, right? So let us write a definition of fluid mechanics. It is the science which deals with fluid. Fluid means liquid or gases. Liquid or gases. Anything which can flow in rest or motion. So basically we are dealing with fluids which are either in rest or in motion. Now my question to you guys is, what is a fluid? Because all of us understand what is rest, what is motion, right? But do we understand what is a fluid? Because for to study fluid mechanics, you have to understand both of these words, what is a fluid and what is mechanics. For mechanics we have defined this part, but for fluid we have yet to define it. Okay, then comes our second subtopic, which is fluid versus solid. Like, what is fluid, how it is different from solid. Okay, so I will take two cases. There is case, let us say for part A, we have this, let us say this is my ground, and I have this metallic block or wooden block or whatever it is. Let us say it is a solid block, right? This is a solid block here. Now what I am doing here is I am applying a shear stress on this surface. What will happen? The body will deform something like this. Right? The body will deform like this. Let us say at some angle phi. Shear stress is proportional to shear strain, this angle phi. Whatever, as I will increase the shear stress, it will increase the shear strain. If I decrease the shear stress, it will decrease the shear strain. That is what is meant by this proportionality sign, right? And to remove this proportionality sign, we introduce a constant g, which is tau by phi. This g is called as modulus of rigidity or shear modulus. Modulus of rigidity or shear modulus. We are applying shear stress and shear strain is being developed. So this modulus is called as shear modulus. Right. So this was about solid. What happens in solid? Okay. I will. Let us take. Okay. So I will make one graph here. Let us say for x-axis I have a shear strain phi. For y-axis I have shear stress tau, and I will plot this. So here we can easily see shear stress is proportional to shear strain, right? Shear stress is proportional to shear strain. As shear stress is increasing, shear strain will also increase. So the graph will go something like this, a straight line graph. And I think if you guys have a little bit of idea about strength of materials, and in class 11th also you guys have studied this stress strain relationship. It goes something like this. This is the fracture point, right? So my purpose of drawing this part here is for value of shear stress tau 1, we have a value of shear strain phi 1. For value of shear stress tau 2, we have value of shear strain phi 2. Right, this is what this direct proportionality means. For one value of shear stress, we have one value of shear strain. Correct? Now this shear strain, this phi, can be written as one more thing. We can write it as phi is inversely proportional to G, right? Modulus of rigidity. How I can write this? Because G is equal to tau by phi. If I take phi that side, it will become tau by G, keeping shear stress as constant. I can treat phi as inversely proportional to G. And in this case, obviously, I'm talking about when shear stress is not zero, when we are applying some shear stress. At that condition, if there is no shear strain, if phi is zero, this implies modulus of rigidity will tend to infinity. This kind of body, which shows no shear strain, even after applying shear stress, is called a rigid body. I think you guys have listened these terms before, right? You know these terms. What is rigid body? What is elastic body? Those kind of things. And if you don't know, you don't worry. You will study these things again in strength of materials topic. Okay, so this was a little bit introduction about solids. What happens in solids? Now let us enter into the domain of fluids. What happens in fluids? Now again, I am making one reference ground level. Again, I will take one test element, but earlier it was solid. This time it is fluid. Right. Again, I am doing the same thing. Again, I am applying some shear stress on this surface. Now what will happen? Now things will change a little bit. Let us say,
Continuous deform, sir.
okay. Let us say at some time t1, we will get fluid element like this. At some time t2, we will get our fluid element like this. At some time t3, we will get our fluid element like this. Basically, this will be at time t1, at time t2, at time t3. So t1, t2, t3. Okay. So our fluid element will change. It will change shape, right? Earlier also it changed shape. Right now, in this case also it will change some shape. But what is the difference here? Let us say this is the angle phi 1, this is angle phi 2, and this whole is angle phi 3. In earlier case, our shear stress was proportional to shear strain. For one value of shear stress, we were getting one value of shear strain. We were getting a straight line curve here, straight line graph here, right? Directly proportional graph. In this case, I have applied a single value of shear stress. A single value of shear stress is there, but I am getting multiple values of shear strain. Shear strain is dependent on time. It is a function of time. Shear strain is changing. So here shear stress, earlier shear stress was proportional to shear strain, but now it is proportional to strain by time or strain rate. In differential terms, I can write tau proportional to d phi by dt, where this d phi by dt is called as shear strain rate. How shear strain is changing with respect to time. Rate of shear strain, right? Earlier it was a constant shear strain value. Now the shear strain value is not constant. It is changing with time. Even though we are not changing the shear stress values. So earlier, to remove this sign of proportionality, we introduce a modulus of rigidity, just G, right? Again, we have to remove this constant of proportionality. So we will introduce a new term called mu. Tau will come out to be mu d phi by dt. Now this mu thing is actually very important. We will study about it in great detail. So for now, let us say this mu will come out to be tau divided by d phi by dt, right? And for shear stress to be constant, I can, for let us say one case where I'm not changing shear stress. So mu is inversely proportional to rate of shear strain, right? So I can say one thing. Okay, let me name this part first. This mu is called as dynamic viscosity, or simply few people call it as viscosity. In some paper, if okay, so I will write it as dynamic viscosity or simply viscosity. If viscosity is mentioned or dynamic viscosity is mentioned, you will always assume it to be mu. Why I'm telling you? Because there is one more kind of viscosity which is called as kinematic viscosity. So when we will study this viscosity part in detail, most probably tomorrow, or in next class we will study this. Then I will introduce you with a new term called kinematic viscosity, and we will see what is the difference between these two things. Okay. So here what I did here is I wrote here that mu is inversely proportional to rate of shear strain. So as rate of shear strain will increase, mu will decrease, or vice versa, right? So let us say I have two cases here. Let us say I have two fluids, basically two different fluids are here. One fluid element is like this, and the other fluid element is like this. Right, okay. And I'm applying same value of shear stresses on both of them. Tau is same for both of the fluids, and both of the fluids will have some deformation, right? Let us suppose this fluid deform like this, and this one, let us say, deform like this. So we have this angle as phi 1 and this as phi 2. And let us say this deformation took dt time in both the cases. Right. So I can write, since time is same in both the cases, I can write d phi 1 by dt is less than d phi 2 by dt, because phi 1 is less than phi 2, right? Phi 1 less than phi 2, so d phi 1 by dt less than d phi 2 by dt, right? And since viscosity is inversely proportional to shear strain rate, I can write mu2, or I can write mu1 greater than mu2. This means I can say for same shear stress, fluid 1 is showing less deformation. This means it is more viscous. This means mu1 is more than mu2. Right? Is there some doubt, or is this picture clear?
Clear.
Sir, sir, mu1 is having more stress or what, sir?
See, stress is
When
same in both. Tau value is same in both the cases. Time is also same in both the cases. Only difference is these shear strains, angles, phi 1 and phi 2. Right? So this means we can conclude for same shear stress at same time, if some fluid is giving you less deformation, this means that fluid is more viscous. So with that, we introduce a new property called as fluidity, which is nothing but 1 by mu. So you can, okay, so it is known by F. So I can write mu1 greater than mu2, or I can write F1 less than F2. Fluidity of 1 is less than fluidity of 2. Actually, nobody uses this property called fluidity, but still for sake of information, I am telling you that there is something called fluidity, okay? But in most of the cases, you will deal with mu only. Right, so with this whole discussion, we got into one conclusion. What is a fluid? So a fluid is a substance which is capable of flowing or deforming under the action of shear force, however the small that force may be. In solids, the deformation is almost constant for a given stress. In fluids, the deformation changes with time. So in fluids, rate of deformation is more important than the deformation itself. It's clear?
Yes, sir.
Right. So I have given you three statements. Statement number one, a fluid is a substance which is capable of flowing or deforming under the action of a shear force. Doesn't matter how small the force is. Point number two, in solids, the deformation is almost constant for a given stress. Point number three, in fluids, the deformation changes with time. So in fluids, rate of deformation is more important than deformation itself. Right? So these are the three very important points. Okay, so will you guys write those points yourself or should I write them? Should I write
Sir,
them?
you better. Yes, sir. You better write, sir. I will note it.
You don't need to note it then. Okay. Okay, I will write it so you guys can read from your notes, no problem. Okay, so we have this point number one here. What is a fluid basically? A fluid is a substance which is capable of flowing. And what does this term flowing means? Continuous change of shear strain,
Yes, form.
right? Flowing or deforming under the action of shear force. However small the force may be. Right. Point number two. In solids, the deformation is almost constant for a given stress. Basically, for one value of stress, we have one value of strain. But in fluids, I will write in next page. In fluids, the deformation changes with time. So, in fluids, rate of deformation is more important than deformation itself. Right? So I will summarize. I will make a summary table actually. Solids versus fluids. what are the things we have studied. So for solid, we have tau proportional to phi. We have tau is equal to g5, right? For fluids, we have tau proportional to d phi by dt, and we have tau is equal to mu. Okay, one second. Yeah, mu d phi by dt. Correct. I think
Yes, sir.
this table summarizes whatever we have studied till now. You guys have got a nice picture of what is a solid, what is a fluid. Okay. So till here, any doubts?
No, sir.
Okay, nice. So I think we have seen a nice definition of fluids. We have seen what is fluid mechanics. We have seen the comparison between solids and fluids. Okay, so now let us enter into the next topic, which is the topic of continuum, concept of continuum. Concept of continuum. Okay, so have you guys joined this WhatsApp group which we have for all the batches? So fluid and thermo, I think one WhatsApp group is there. Are you guys aware of this WhatsApp group? Hello? Yes, right. So you guys have joined this WhatsApp group. Okay, so few people are not aware of this.
So this is our demo class actually. That is why we do not know about any other WhatsApp groups.
Okay, no problem. Okay, so if you guys decide to continue further for next class, so I think you guys will get a link for a WhatsApp group which we have. So in that WhatsApp group, you guys can discuss among yourself whatever doubts you have. You can just put the question there. If I have time or any else teacher has time, they will respond to that query. Okay, or you can tag us also, and like let us say I have taught one topic in fluid mechanics, and after that you are solving some question, and you have doubt in that question. You just click a photo, put it in WhatsApp group, and somebody will respond or I will respond within few minutes or after 1 or 2 hours. Okay, so that's a very nice platform to practice very new questions. And one more thing I wanted to tell you, like in class, I will solve few questions. Suppose after class, let us say I'm reading some book or I'm looking at some previous year question. I find a very nice question. I will upload that question in WhatsApp group. So, and I expect you guys to look at that question and try to solve it before coming to the next class. Okay. So this will be kind of your homework. So, okay, so we can start this concept of continuum. Okay, so you guys have studied thermodynamics also in your BTech days, obviously not here. So there is one thing called continuum. One thing is called rarefied gas theory. These are two, you can say, two extremities of a large spectrum. So let us start this. Let me say this is a fluid column. A fluid is flowing like this. It is a fluid column. Okay, and I will take a test element here for my analysis. I will mark an area or mark a volume for my analysis. Whatever I want to check. Let us say I want to check what is the how the acceleration is changing, or how the velocity is changing, how the pressure density, whatever property I want to check. I have marked this volume in this flow, and okay, let us say the fluid is flowing in this direction. and I have marked my volume here. So this kind of area of interest is actually called as control volume. Control volume, or in short, I will write it as CV. Okay. We can call it as CV, control volume, right? So for my control volume, this is nothing but my area of interest. My area of interest. Like in thermodynamics, I think you guys are familiar with this term called system and surrounding, right? So system is what? The part of the universe which is under your consideration right now, on which you are focused, like what changes this part will show me. That is your system. Anything away from the system or external to the system is surrounding for you. And that system plus surrounding makes complete universe. Right, this is the first topic which is taught in thermodynamics class. I think you guys remember this part. So in fluid mechanics, we call that system as control volume, nothing else. It's not a new thing, right? So for that control volume, let us say there is one thing called characteristic length, LC. Characteristic length, it is written by LC, or some people call it as characteristic dimension also. Characteristic dimension. It doesn't matter what you call it, at the end of the day, it is a length, nothing else. So this is the length which is used to define dimensionless numbers. We have a topic which it is actually a last topic in this subject called dimensional analysis and similarity. Right. So in dimensional analysis, I will explain you what is this characteristic length, what are dimensionless numbers. But still, for time being, I think there's a very famous dimensionless number which you guys already know called Reynolds number. Right? You guys already know this part. This is what I'm assuming. If somebody is not aware of Reynolds number, they have not heard about it. Please tell me now. Otherwise, I will assume that you know that you have heard about this name. Okay, so everybody has heard it, right? So this Reynolds number, what does it tell you? Whether the flow is laminar or whether the flow is turbulent, right? This Reynolds number tell you this thing. What is this Reynolds number? How it is defined? So those things we will discuss in dimensional analysis chapter. But still, for a little bit of introduction, I'm telling you that Reynolds number tells you whether the flow is laminar or turbulent. What is laminar flow? What is turbulent flow? Again, we will discuss these things later. Don't worry about it. Okay, so for a little bit of idea what is laminar and what is turbulent, I will give you a very nice example. Let us say this is an okay. Let us say this is an incense stick, right? And the tip of incense is burning. Obviously, it will leave some smoke, right? It will leave smoke like this. I know it is looking like something else also. You guys can assume that thing also. Don't worry. But for me, let us say it is incense stick. So you will see the smoke lines initially. The smoke lines will be traveling in very smooth manner. Smooth motion of smoke lines. Right. Initially, they will travel very smoothly. After traveling some distance, they will go like this. They will go something like this. One line will go like this. Something like this. Some haphazard motion will start. Right. I think all of you have observed this. So this is what? This is haphazard motion, and this is the smooth motion. Now this haphazard motion, this actually corresponds to turbulent flow. This smooth motion, this corresponds to laminar flow. So I'm just giving a very basic idea, like how you in your daily life, when you see laminar and turbulent flows. Correct?
Sir, I cannot understand, sir, the difference.
Okay, so you have never seen an incense stick,
Yes, sir.
or for that matter, if you smoke, have you ever seen somebody smoking a cigarette?
Yes, sir.
Yes, you have seen it, right? So near the tip where it is burning, the smoke leaves in very smooth manner, right?
Yes, sir.
After traveling some distance, the gas particles disperse
Yes, sir.
and they move in their own directions. They are not moving together, or they are not moving smoothly.
Yes, sir.
So these are two different kinds of motion of fluid, motion of smoke particles in that regime. So the one which is smooth, that kind of motion is called laminar flow, and the one which is haphazardly moving, that kind of flow is called as turbulent flow.
Okay, sir. Okay, sir. Now I
I
understood,
am
sir.
giving you a very crude example right now, but
Yes, sir.
still for initial purposes this example is okay. So let us understand what is laminar, what is turbulent very crudely for now. When we will enter deeply into these topics, then I will explain you mathematically, explain you in the terms of fluid mechanics how these flows develop, and what is the basic difference between these flows, right? And why do
Yes.
we mostly focus on laminar flow in BTech only? Because turbulent flow only introduction part is there. There is not much in your GATE syllabus. So still, I will give you some introduction, like why turbulent flow is a very difficult thing to understand. Okay, so there is one dimensionless number called Reynolds number, named by this scientist Reynolds, and it tells you whether the flow is laminar or turbulent. Correct. Similarly, there are various kind of dimensionless numbers. There is one number there is called Knudsen number. I will introduce you that number now. So actually, whenever we choose a system and we want to define a dimensionless number for that system, we need a length scale. That length scale is called as characteristic length, or LC. Right. Let us say for this control volume, this length is LC. Let us assume. Okay. And there are n number of fluid particles inside this control volume. Let us say there is one fluid particle here and one fluid particle here. And we all know that inside a control volume, when there are n number of fluid particles, it is natural that they will collide into each other. There will be collisions between different fluid particles, right? So there will be collisions. And there is fluid particle, again, they will collide into each other. This fluid particle, this will collide, they may collide. Something like this will be happening, right? Now there is a term called lambda, which is called mean free path. What is this mean free path? It is the average distance which a fluid particle has traveled since its last collision. Okay, try to understand this definition. Since its last collision. Okay, so this is lambda. Now I will make one control volume here. Okay, this is my control volume, and there are molecules inside, or fluid particles inside it. right? Let us suppose there are some number of some number of fluid particles here, and obviously they will collide into each other. Right, something like this. And I have one more control volume. Let us say this is the control volume. Let us say this is CV2, this is CV1. Okay, control volume 1, control volume 2. And in this control volume 1, we have this only three, let us say only three fluid particles are there. They will collide, they will also collide into each other. It doesn't matter, right? Okay, so this lambda or mean free path is the distance which a fluid particle has traveled since its last collision. Tell me, okay, let us say this has lambda 1 as mean free path, this is lambda 2 as mean free path. What will be larger, lambda 1 or lambda 2?
Lambda.
For time being, as okay, let me complete it. For time being, assume both control volumes are of same size. I have drawn them differently, but let us assume the size of control volume is same. Now tell me what will be, lambda 1 will be bigger or lambda 2 will be bigger?
Lambda 1, sir.
Lambda 1 will be bigger, right? Because number of fluid particles is less in the same control volume,
Yes, sir.
right? I am
Yes, sir.
telling you size of control volume is same. So what do I mean with this is the characteristic length LC of the control volume 1 and LC of control volume 2 is same. LC1, LC2. So I can write LC1 equal to LC2. This means the size of control volume is same, but still lambda 1 is more than lambda 2. Why? Because the number of molecules is less in CV1. Correct. So mean free path of control volume 1 will be more than mean free path of control volume 2 because the difference in number of the number of fluid particles. Now comes the concept of continuum. This is my density. In y-axis I have made rho or density curve. Density simply means how densely fluid particles are packed inside a control volume. I can say density of 2 is more than density of 1. Mean free path also be affected by velocity of energy of particles. Let us assume they are same in both the cases. I am telling you like everything is identical in both the control volume, only the number of molecules is difference. Energy, velocity, everything is identical for both the control volumes. Okay. So we can say that rho 2 is greater than rho 1 because number of particles is more in the same volume. Right. So for density, let us say when that, so the graph shows something like this. This is the limit where we say, and then y-axis actually is the volume. So let us say this is some volume, let us say dV. Okay. So in this, when the volume is more than dV, so characteristic length is more than mean free path. When when volume is less than dV, in this case, mean free path is more than characteristic length. So only in this zone, continuum is applicable. Basically, what we are trying to tell here, we are saying that the size, what does the characteristic length tell you? The size of control volume. The size of control volume is much bigger than the mean free path. This means the fluid molecules are very much densely packed inside the control volume. So we can assume the fluid as a continuous medium. We do not need to assume these molecules, we do not need to analyze this fluid molecule by molecule. We can assume, okay, this is a continuous medium, right? But if mean free path becomes more than characteristic length, then in this case you can say that uh, our molecules are so far away from each other that sometimes they are getting out of your control volume, sometimes they are getting inside the control volume. So in this case, you have to analyze each molecule in itself. That's why in this zone, the analysis which we use is called as rarefied gas theory, because the gas molecules are very rare here. It's called as rarefied gas theory. And more than that, we have continuum approach. So in your subject, in this fluid mechanics subject, we will always assume continuum approach. Continuum is applicable everywhere for us. For in this subject, wherever we will do any kind of analysis, we will assume this. We will not assume anything molecule by molecule. We will see that it is a continuous medium. Fluid molecules are fluid particles are one after the other. So whatever will happen in this fluid particle, the same kind of property change will happen after some time in the same control volume. Is it clear? Any doubts? Okay. Now we will enter into our next subtopic, which is called as no slip phenomenon. No slip phenomenon. Okay. Let us say this is a solid surface, a metallic plate. Let us assume it as like this. And then I have this fluid coming from this direction. And this fluid has some viscosity mu and some velocity, free stream velocity as u infinity. This free stream conditions we generally denote with this infinity symbol. U is velocity, it is a free stream velocity, it is infinity, u infinity. And what do you mean by a free stream? Basically, it is not flowing near any solid surface. Then I call it as free stream. And the solid surface will start from this point. This is the leading edge of the plate. For now, let us say the speed of this surface us is 0. It is at rest. Now what will happen? This lowermost layer of this fluid will interact with the plate first. Right? Now what does this no slip phenomenon tell you? It tells you that fluid particles will not slip over the solid boundary. They will stick over this solid surface. This is the no slip boundary condition basically. With respect to the solid boundary, the relative speed of the particles will be 0. So I can say fluid particles velocity will also be 0 here. Correct? Now there is one more layer which was flowing above this lowermost layer. Now its molecules will start flowing over it. They will go something like this. Correct? But there is some kind of force, interactive force between these fluid molecules. Right? Some attraction force is there This kind of force is called was cohesive force. Cohesive force is there between fluid molecules. Now what this cohesive force will do, this molecule is stick to the plate due to no slip phenomenon. Now this upper layer molecules are trying to flow over these molecules. Now due to this cohesive force, they will pull these one. They will pull the upper molecules. Similarly, the fluid molecules of the upper layer will go something like this. They will also want to go here. They will also be pulled like this. Then again, they will also be pulled like this. Similarly, slowly, a layer is being formed over the plate. Can somebody guess what is the name of this layer?
Boundary layer, sir.
Nice. So this is your boundary layer. Right. Now at any cross section, let us say I mark this as my cross section for analysis. I want to draw the velocity profile. I want to check what is the velocity. For the lowermost layer, the velocities are 0, right? Because they are sticking to the plate due to no slip. The layer which is just above it, these molecules have moved a little bit of distance, so they will have some little velocity. They will have some velocity, but the velocities will be very less. As we will move a little bit further away from the plate, the velocities will be a little bit more, and again they will increase as we are going away from the plate. So our velocity profile will become something like this, and at the edge of the boundary layer it will be close to u infinity, or I should write it as 0.99 of u infinity, 99% of u infinity. And after the boundary layer, effects are not there, so it will be u infinity. Correct? Is this whole picture clear? How boundary layer is forming and how velocity profile is being generated? You guys should remain active. Either write your responses or speak. Otherwise, I will keep on speaking and you guys will sleep. So try to remain active. Okay. So I can say one thing, like when viscous fluid. So why is whole this thing happening here? It is due to no slip phenomenon, right? Due to no slip phenomenon, what happened? The lowermost layer stick to the plate. After that, what happened? After that, cohesive forces came into action. And these cohesive forces basically are due to presence of viscosity. Yes, there are particles available. See, I have made this boundary layer so much thick, but it is not like this. It is a very thin layer. This I have zoomed in, you can say. That's why you are thinking that, okay, so this free stream only had 4 velocity lines, but after that there will not be any molecules. So it's not like that. Actually, it will look something like this. I am not sure if I will be able to draw it correctly, but still, no, actually it is correct, but not up to scale. Let us say the fluid particles are like this, they are coming like this, okay. So over the plate, if I want to generate a boundary layer, it will be like a very thin region. So the velocity profile will be like this, parabolic like this, and then there will be no velocity gradients above. So u infinity, and there will be some less than u infinity. Right. So I have actually zoomed in this part to explain this to you, this part. So you don't think that, okay, so boundary layer is very thick. It's a very thin portion in fluid flow. Okay. So when viscous fluid flows over a solid surface, bulk of the fluid molecules acquire the velocity of the surface, which is called as no-slip phenomenon. Let us suppose this surface is moving with that with some velocity. In this condition, we have told that surface is at rest, US is 0. Let us suppose it is moving with some velocity. So the lowermost molecules will also start moving with the same velocity. Basically, relative velocity between the surface and the near about the layer will be 0. Right. Basically, this bottommost layer will not slip over this solid surface. So this means when viscous fluid flows over a solid surface, bulk of the fluid molecules acquire the velocity of the surface. This sticking phenomenon is known as no-slip phenomenon. Right. So is this part clear? No-slip? Okay. Okay, so after see, we have covered this basic introduction part of this chapter, or you can say introduction part of fluid mechanics. 1 second. Yes, so we have covered this part. We have covered definition of fluid versus solid, continuum, and no slip. These parts we have completed. Now we will enter into the domain of, will these topics be taught again? So why do you want to listen to these things again? No, actually, why do you want them to be taught again? I want to know. If some of your friend want to join in next class, or is what is the reason here? Lost your network.
This one is the demo
It does
class.
not. You will get your recorded lectures also. Don't worry, you will get recorded lectures, so you can listen to these things again. That's why I'm recording. You guys can see on your screens, right? It is being recorded. Class is being recorded. So whatever you guys are writing in between and whatever I'm telling, all of these things are recording. And this recording also you guys will get. Don't worry. You guys will get these notes also. So no need to worry about anything. Okay. So, and I will suggest you guys not to depend on these notes because there are many things which I speak and do not write here. So I will suggest you guys to again after this class again listen to the recorded lecture and make your own notes basically. Okay. So actually today I was told to take 1.5 hour class only, but if you guys want me to continue for another half an hour, then we can start fluid properties, some very basic introduction. Okay, so we will enter into the domain of fluid properties then. Okay, so we'll study for another half an hour. Or let me see what topics we have. Okay. Okay, so we will start with fluid properties. What are various fluid properties which are important for us to study? First of all, we will study mass density, or simply known as density, denoted by the symbol rho. Right? I think all of us know this mass density is basically mass per unit volume. So units are kg per meter cube, right? Okay, volume. Okay, so I will do one thing. This V actually it will again come in this subject. So this V will be sometime it will be treated as velocity. So to not get confused with velocity, for volume I will write V something like this. I will strike it horizontally. Right. So this symbol is actually for volume. Okay. So mass per unit volume. So it is defined as mass per unit volume at a specified pressure and temperature in the fluid, because densities change with pressure and temperature. So if let us suppose at 4 degrees Celsius I am talking about, let us suppose I am talking about 4 degrees Celsius and 1 atmosphere pressure, density of water will be 1000 kg per meter cube. Now when I am talking about 20 degrees Celsius, I have increased the temperature, but my pressure is same. What do you think density will be? Will it increase, decrease, or remain same? I have increased the temperature, pressure is same. Density will increase,
Same density.
it will decrease. Right? So density of water is close to 998 kg per meter cube. Now let us say we keep the temperature constant 20 degrees Celsius, but I increase the pressure 100 atmosphere. Now what will happen? Density will increase or decrease? I am increasing the pressure. Density will increase or decrease?
Decrease, sir.
In- increase, increase. See what is happening here. Density tells you how closely the fluid particles are packed, right? So when in first case, pressure was same, 1 atmosphere, but I increased the temperature. So with increasing the temperature, kinetic energy of the molecules will increase. With kinetic energy, molecules will move further away little bit. So the density will be decreasing here. When density molecules are moving further away, their mean free path is increasing. So they are getting less closely packed than earlier. This means their density is decreasing. Now, in second case, what I did, I kept the temperature constant, but I increased the pressure. When I will increase the pressure, the mean free path of the molecules will decrease. They will keep interacting with each other more closely, so lambda will decrease. So you will see that the density, molecules are more closely packed. You can assume it as a piston cylinder arrangement. When I'm increasing the pressure means I'm pushing the piston inside the cylinder and I'm decreasing the volume. Right? So densities will increase. So this is the case. Okay, we have taken density of water as example. Water is a liquid, right? So what happens? In liquid, let us say in 20 degrees Celsius, temperature was constant. I increased pressure 100 times, 1 atmosphere to 100 atmosphere. What was the change in density? It was 998, 1007. It was close to what? How much percent change is there? What is the percentage change from 998 to 1007? You guys have calculators. Can you do it? Actually, it's less than 0.9%, right? It's approximately 0.9%. So you can say 0.9% increase. So in liquids, okay, so I will write a note here. Liquids, changes in density with respect to pressure are negligible. 0.9% is negligible. Less than 5% we treat it as negligible. Therefore, liquids are treated as incompressible. Liquids are treated as incompressible. Now what about gas? Fluids are of two types, right? Liquids and gases. Now for gas, let us take example of air. Okay, so for air, let us say I'm giving you this data. So let us say if you want to use this data anywhere in the question, you can remember it. Density of air at 1 atmosphere is close to 1.23 kg per meter cube. Right. So if density changes are less than 5%, we treat it as incompressible. Otherwise, it will be compressible. So this was the first property, mass density or density, whatever you would like to call it. Then we have our second property here, which is called as weight density. Or some people like to call it as specific weight. So it is denoted with small w or gamma, right? So this small w is, so mass density was mass per unit volume. This weight density is what? Weight per unit volume. So its units are Newton per meter cube. Earlier this was kg per meter cube. So I can write it as mg by v, and m by v is what? Rho. So rho g. So this specific weight w or gamma can be written as rho g. Right? Few numbers I am giving you. Specific weight of water. Rho g. Rho means density of water, 1000. G is what? 9.81. So specific weight of water will be 9810 Newton per meter cube. Then there is one, and this is SI unit. This Newton per meter cube is actually SI unit of weight density. Then there is one unit system which is sometimes it is shown in the questions. 1 kilogram force. This force is actually equal to force applied by 1 kilogram mass, which is nothing but 9.81 newtons. 1 kilogram force is 9.81 newtons. So if I write this specific weight of water in terms of kgf, it will come out to be 1000 kgf, and this will be in units in the MKS system. MKS means meter kilogram second. MKS is meter kilogram per second. Meter kilogram second. MK systems of unit meter kilogram second. Then there is a CGS system of unit centimeter gram second. Then there is FPS system of units foot pound second. Basically it used in America only. Foot pound second. Right, so these are three systems of units. I think you guys have studied these in class 11th or so. Right. Okay, so then we have our next property called relative density or specific gravity. Relative density, and we will have its subtopic as specific gravity, which will be useful for you guys. In many questions, this is given. So relative density RD is actually density of one fluid with respect to some standard fluid, right? Or you can say not standard. You can say relative density is density of one substance with respect to some another substance, right? Rho 1 with respect to rho 2. Basically, it's relative to that. Its subtopic or its special case is called as specific gravity. Specific gravity. What is specific gravity? It is a relative density with respect to some standard fluid uh, for liquids. Standard fluid will be standard fluid is water for actually for liquids and solids. And for gases, standard fluid is air. Okay, so this specific gravity, actually, if I want to calculate specific gravity of any fluid, what will I do? I will take density of that fluid and I will divide it with some standard fluid. Let us give me an example. Specific gravity of mercury, Hg, is equal to density of mercury. Mercury is a liquid, so standard fluid will be water. So density of mercury is 13600 kg per meter cube. Density of water is 1000. For most of the cases, you can treat density of water as 1000 kg per meter cube. So the specific gravity of mercury will be 13.6. And since it is a ratio between two same quantities, so it does not have any units. Right. So density of mercury also has kg per meter cube, water also has kg per meter cube. So those units will cancel out and it will be a dimensionless quantity. Correct? And let us say for solid, specific gravity of wood, if it is, let us say it is given as 0.6 to you. So what does this mean? This will mean that density of that wood will be 0.6 multiplied by, for solids also, the reference fluid is water, right? 0.6 into 1000. So it will be 600 kg per meter cube. Correct? Is there any doubt till now?
Question, sir. It should be divided by, sir.
No, in this case, you have been given specific gravity. You have to calculate density. In case of wood, you are talking, right?
Yes, sir.
Is it clear?
Yes, sir.
In case of mercury, I asked you specific gravity and I gave you both the densities. So you divided it. In case of wood, let us say specific gravity of wood is given as 0.6. And you have to calculate density of that wood. So for solid, standard fluid is water. So I will multiply with the density of water then, right?
Yes, sir. Yes, sir.
Clear, right? Okay, so we will stop today's class for now. And hopefully, if you guys join this WhatsApp group, or some people have already joined, I will send you one question in WhatsApp group. So just think about it. And in next class, whoever would like to join again, you are most welcome, and try to solve that question before coming to class. Okay, so now I will share these notes with you. So in this chat, you will get the download link. So in, I think in 1 or 2 minutes. 1 second. Okay. Okay, I wrote a few things in this file also about some gate exam. So do you guys need this part also, or only the course part?
Sir, we need this part also, sir.
Okay, this part also. Okay, okay. So I will upload this part also.